All right, here is example 1. Remember that it's always a good idea to pause these if you miss something, if you need to write something down, or to rewind a little bit. But for example 1, we're going to look at vertex form. So let's remember that if something is written in this form, a times x minus h quantity squared, and then plus k, then that's going to have something with that as the vertex. So for example 1, let's see, we're going to write a formula for each function with a. A is the same thing in all the different forms, where a is positive or negative 1. Now let's see, the vertex is up here somewhere, but it's not really clear what that is. We don't actually have a scale on the axes here. Like, I don't know if this is going up by 1, 2, 3, 4. Is that like 4.5, or is it something else? I'm not sure. Or maybe it's going up by 2, 4, 6, 8, or 10, 20, 30, 40. So the vertex, we don't really know what that is. But what we do know about it is we have the x-intercepts here. We've got this point, -2, 0, and this point here, 4, 0. So if you know the x-intercepts, you know the values of x that make the result, the value of y, equal to 0, then you can write it in factored form. So that's what we're going to do here. We're going to write it as f of x equals a times, let's see, we want to have x minus -2, because -2 is a value of x that makes that equal to 0, times x minus 4 is the other part. So the x minus -2 you can just write as x plus 2, of course. And then, let's see, so now this is something, no matter what number a is, if you plug in x equals -2, you'll get a result of 0. If you plug in x equals 4, you'll get a result of 0. But what is the a? Well, it's given that a is positive or -1. So let's see, is it positive 1 or -1? Well, because it's opening downwards here, we can say that a must be -1. So that is a formula for that function. All right, how about this one? Well, this time you do know the x-intercepts, but we also know the vertex here. This time it's given that the vertex is 2, 1. So you could write this one as f of x equals a times, let's see, it's going to be x minus h. The h is the x-coordinate of the vertex, which is 2. And the k is the y-coordinate of the vertex, which is -1. So we're going to write this as x minus 2 squared plus -1. And the a is either positive or -1. In this case, it's going to be positive 1 because it opens upwards. Okay, so let's see. So you could write it like that. If you just have 1 times x minus 2 squared, you could just write that as f of x equals x minus 2 squared minus 1. You don't really need to write the positive 1 times that there. Now the other way to do this is, what if you tried to use the x-intercepts? You could do that too. You would write that as f of x equals positive 1 times x minus 1 times x minus 3. And are these really the same thing? Well, we could FOIL it out and see if they work out the same. Let's see, if I FOIL this out, you're going to get x squared minus 1x minus 3x gives you minus 4x. -1 times -3 is positive 3. So that's that. And then what if you wanted to FOIL this one out to see if that gives you the same thing? That would be x minus 2 squared. This part is going to turn into x squared minus 4x plus 4. We got that minus 1. So that's going to be x squared minus 4x plus 3. So yeah, those are the same. Either way you want to do it should give you the same result. Okay, this one, however, the third one here, has no x-intercepts. So that means it's not possible to write this one in factored form because there's no r into s. There's no value of x that makes the y equal to 0. So this one can't be written in factored form, but we do know the values of h and k. The h is the the x coordinate of the vertex. So you have h equals -3, and you have 2 equals k there. So, and let's see, that because this opens upwards, the a is going to have to be 1 for this one, because it must be a positive number. So this one you could write as f of x equals +1 times x minus -3 squared plus 2. That's x minus h plus quantity squared plus 2 plus k. So you could also write that in slightly simpler form as f of x equals x plus 3 squared plus 2. And yeah, something to notice here is that if the h is a negative number that we have here, then subtracting a negative number ends up giving you a positive result there. So you can write it that way. All right, let's go on to example 2 here. That nice garbage truck in the background. So let's find a formula for a quadratic function with zeros at x equals 3 and x equals -5, and with y-intercept 0, 12. So by the way, the zeros, this is a fancy way of saying x-intercepts. These are values of x that make the function output become 0. So we want to get f of 3 equals 0 and f of -5 equals 0. So if that's what we want to have, then we can write it in factored form. We can say this must, like looking back here at the previous page, factored form tells you the zeros, also known as the x-intercepts. So in this case, let's say that it's going to be f of x equals some number a, that's unknown, times x minus 3 times x minus -5. But, okay, so that's going to have the right zeros, the right x-intercepts. If you plug in 3 or -5, the result will be 0. But what is a? Well, let's see. There's other information we haven't used yet. When they say the y-intercept is 0, 12, we haven't used that yet. So we're going to find a using the fact that f of 0 equals 12. So let's do that. Let's plug in x equals 0 here, which is going to be a times 0 minus 3, and then 0 minus -5 is 0 plus 5. So, and that result, we know, should come out to be 12. So that's saying f of 0 is 12. And this gives you an equation that only has a in it. That's the trick here. And you can figure out what this a must be to make this fact true, to make this be a point on the graph. So let's see. We can do -3 times 5. That's going to give you a times -15 equals 12. And then to find a, you can just divide both sides by -15. And that will cancel out to give you a equals, you can reduce this fraction, it should become -4/5. So that you can now say is the formula for this function with that value of a. F of x equals negative 4/5 times x minus 3 times x plus 5. All right, so next up you have a couple exercises like this. Remember, when you do these exercises, it's a lot better to figure it out yourself. I recommend using these examples 1 and 2, rather than using the exercise videos if you get stuck. And we'll do that next.